So let's take a look at how many samples we need to get a simulated power level of 95%. So again, this is averaged across all of the distributions studied, and the required sample to get 95% power varies. So we look at the Anderson-Darling and Jarque-Bera. They're both greater than 2,000. And that's because at the maximum sample size, 2,000, these distributions seem to asymptotically approach 92. If you remember, that was because if we looked at just the symmetric data from earlier, that approached about 80, and the asymmetric approached about 100, so it never really got above that 92% because of that. The KS test also never approached 100, but instead of approaching 92, it only approached 16.6% and actually reached a maximum of 18.4% around 100 samples. So as the sample size increased, we actually saw the KS test go down a little bit, which was pretty interesting. Lilliefors, even though it was ranked at number 2, it actually converges onto 100% very quickly, with that 95% simulated power being between the 50 and 100 mark. In this study, sample sizes weren't taken between 50 and 100, so that's why there's that range there. Further studies will be needed in order to pare that down and get a more granular view of where that actually occurs. The Ryan joiner gets to 95% right around 400. It's like 400. At 400, it's at like 94%, so it's really close to 400, close enough for an engineer. And then the Shapiro-Wilk Royston, similar to the Lilliefors, converges on that 95% between two different sample sizes checked. That's at between the 100 and 200. So again, these two just really outshine everything else in this entire study. Definitely the most sensitive tests and highly recommended as your first line of defense.